All right, hello guys. Today we're going to be talking about section 1.3. So the objectives are listed there. After we finish this section, you guys should be able to recognize collinear versus non-collinear. Saying that a point is between two other points. I know that seems very obvious, but I'm just making sure we understand. Recognizing that each side of a triangle is shorter than the sum of the other two sides, and we'll explain that, and correctly interpreting geometric diagrams. So to start with, we're going to talk about collinear. So there's that prefix of co in there, okay? Co means together, and linear means line. So that's exactly what it means. Together, I can zoom in, together on the same line. Okay, so my example for that, if you look over to the side, point G, point T, and point O are collinear. They lie on the same line, the three of them. All three of them lie on the same line. So I would say that those are collinear. Next is non-collinear. So those are points that, you guessed it, do not lie on the same line. And my example for that off to the side is going to be point G, point T, except I'm not going to pick point O, I'm going to pick point M. So if you look at G, T, and M, those 3 points are non-collinear. I understand that G and T are collinear, and that T and M are collinear, and that G and M are collinear, but those 3 together are non-collinear. Okay, so that's what we're looking for. The third thing is betweenness of points. Okay, so we can say that points are between other points only if collinear. So I put two examples off to the side, example 1 and example 2. I can say that point O is between points S and X. Okay, however, I cannot say that point U is between C and B because it is non-collinear. So in your examples, if they say, draw 3 points, and make point B between A and C, you know that B has to be collinear with A and C. The next is the triangle inequality, okay? So for any 3 points, two things can happen, okay? I guarantee it. If I told everybody watching this right now to draw 3 points on their iPad, you are either going to go like this, right? There's an example. Or you're going to go like this. There's 2 types of people in this world, okay? So you are either going to draw 3 points that are collinear, okay? And that means that 1 point is between the other 2 points. That's what that means, okay? Or you drew 3 points that are non-collinear. And if they are non-collinear, they will always form a triangle. And that is where the triangle inequality theorem kind of comes from, okay? So the triangle inequality theorem says that no matter, and this is where I wish you guys were in class, because I took 2 pencils that are exactly the same length, and I would snap one of the pencils, and I'd have somebody try and make a triangle out of it. And it doesn't make a triangle, okay? It does not make a triangle. And that is because these sides, when you take any 2 sides, I wish I could cut this. Can I cut this? When you take, there we go, okay. So when I take this side, and I'm trying not to stretch it or move it, and I cut out this side, it's not letting me do it. Anyway, 2 sides will always be larger than the third side, no matter what. No matter what. Okay, so if I have a triangle and this side is 3 and this side is 5, this side down here could not be 10. That could not make a triangle, okay? Whenever you add up any two sides, it has to be greater than the third side, okay? So any two sides added will be greater than the third side. Okay, so what I mean by this is 3 plus 5 will be greater than 7. 3 plus 7 will be greater than 5, and 7 plus 5 will be greater than 3. Any two sides you grab will be greater than the third side. Okay, and the last thing I want to talk about is assumptions from diagrams. So you guys are going to hear me, you probably already heard me ask in Zooms, I'm like, how do you know? How do you know? How do you know, right? 3x plus 5x, how do you know it's 8x? I'm going to be doing that all year, and you guys are going to hate it, but I'm going to tell you guys right now the things that you are allowed to assume when you look at a diagram, because we're going to be looking at lots of diagrams, okay? So the first thing you can assume are straight lines. So if it looks straight, you can assume that it's straight. I should put and angles in here. Okay, so we can also assume that a straight line is also a straight angle, right? That's a 180-degree angle. The second thing is collinearity of points. So if you look at a segment and you see A, B, and C, you can assume that those are collinear because they're on the same segment. Okay, you're allowed to do that. You're allowed to assume betweenness. And it's all relative. Just because it looks like B is exactly in the middle of A and C doesn't necessarily mean it is exactly in the middle. But I do know that point B is between A and C. I can assume that. Okay? And then again, the relative position. So what that means is point A is on the left, B is in the middle, and C is on the right. We're allowed to assume that, okay? Those are the only things you're allowed to assume right now. Things that you cannot assume. The biggest thing is a right angle. There are so many times where I draw an angle, and I'm like, how many degrees is that? And somebody will be, oh, it's 90. Oh yeah, how do you know? Well, it looks like it's 90. Okay. Cannot go by looks. You absolutely cannot go by looks. Unless you see this little right angle mark, it is not a right angle. So if that's not there, this is not a right angle. We have no idea what that is. We cannot assume. The next thing you cannot assume are congruent. You know what? I'm going to be lazy and I'm going to use the symbol to get you guys used to it. Congruent segments. So if I drew two segments, AB and CD, and I said, are those congruent? You would say, no, we have no idea. Unless you see tick marks on them, they are not congruent. So if I don't see tick marks, those are not congruent. We have no assumption about that whatsoever. This is so important. Same thing with congruent angles. Unless you see the angles with the tick marks on them, boom, boom, like that, and you're like, oh, look, those are, congruent to each other. If you do not see the tick marks, they are not congruent. And same thing with relative sizes of segments. Sizes of segments and angles. So just because something might look obtuse, it's not necessarily obtuse, okay? We have to prove it numerically. The diagrams in the book are not always drawn to scale. We have no idea. Okay, so this is kind of the gist of section 1.3. And then during our live Zooms, I'm going to be going over, obviously, examples about 1.3.